Welcome back, everybody, for another deep dive. This time, we're going to tackle a pretty big question.
Yeah.
One that I think we've all thought about at some point.
For sure.
Where did the atoms that make up you and me and everything we see
Everything.
actually come from?
Yeah.
And, you guys sent in some
Amazing.
absolutely fascinating sources on this.
Really cool stuff.
And honestly, getting to the bottom of it was a real journey.
Absolutely.
So to kick things off,
Yeah.
where do we even begin with this?
Well, I mean, it all really starts with the Big Bang,
Okay.
13.8 billion years ago.
Right.
So picture this.
Yeah.
The universe bursts forth from a single point,
Okay.
unimaginably hot and dense.
So that's the very, very beginning.
That's it.
Beginning.
The beginning of everything.
But were atoms just like there from the get-go?
You're not quite.
Okay.
It was way too hot and
Right.
energetic for atoms as we know them.
To even exist.
Yeah.
So instead you have this crazy mix of fundamental particles.
Like what?
Things like quarks and electrons,
Okay.
neutrinos.
Gotta be honest.
Yeah.
Those are not words that I use every day.
Yeah.
But so these are the building blocks
These are it.
of everything.
Yes.
Wow.
And so as the universe expanded and
Yeah.
cooled,
It's going to cool down at some point.
it had to.
Yeah.
These building blocks started combining.
Okay.
So within the first few seconds,
Wow.
quarks clumped together
Okay.
to form protons and neutrons.
All right. So those are familiar.
Yes.
Those are things.
I
really-
remember,
from science.
and those are the particles that make up the nucleus of an atom.
Wait.
Yeah.
So we're talking the first few seconds.
What's few?
Is the universe, and we already have the ingredients
You got
for atoms.
Yep.
That's wild.
That's just the beginning.
All right. What happens next? So then things get even crazier.
Okay.
Just 3 minutes after the Big Bang.
3 minutes.
3 minutes.
Wow.
The universe cooled enough for those protons and neutrons to start fusing together.
Okay.
This is called Big Bang nucleosynthesis.
Big Bang nucleosynthesis.
And what did it create?
I'm on the edge of my seat.
The nuclei
Yep.
of the first hydrogen
All right.
and helium atoms.
So in just a few minutes,
Just a few minutes.
the universe had the ingredients for the most abundant elements
You got it.
in the entire cosmos
The entire cosmos.
and in us.
Yeah, and you.
That's mind officially blown.
Officially blown.
Okay, but hold on.
Yeah.
We still don't have actual atoms yet, right?
Not quite.
Okay.
We have the nuclei, the
Yeah.
core,
Yeah.
but we're missing something.
What's the missing piece?
Electrons.
Okay.
For hundreds of thousands of years,
Wow.
the universe was still too hot
Oh, yeah.
for those negatively charged electrons to settle down and join those positively charged nuclei.
So everything was just this
There was a jumble
of particles
whizzing around.
whizzing around.
Sounds chaotic.
It does sound chaotic.
It was,
Yeah.
but finally, around 380,000 years
380,000 years after the Big Bang.
after the Big Bang,
Wow.
the universe cooled down to a critical point,
Okay.
about 3,000 Kelvin.
Right. And that's when
That's when recombination happened.
recombination, so the nuclei and the electrons finally said,
Yeah,
all right, things have chilled out.
chilled out.
Let's team up.
Let's do this.
Okay.
And this is where things get really interesting.
Okay, I like where this is going.
Before recombination,
Yeah.
the universe was basically a dense fog,
Okay.
opaque to light.
So you couldn't see anything.
No, you couldn't see anything.
Wow.
But once these stable atoms formed,
Right.
light could finally travel freely.
So it's like
Yeah.
the universe flipped a switch
Flipped a switch.
and went from darkness to light.
That's it.
Hold on.
Yeah.
So you tell me for the first 380,000 years,
380,000 years.
the universe was basically
Basically a dark,
a dark cosmic soup,
yeah.
and then bam, bam, bam.
Like, that's got to be
Pretty dramatic.
one of the most dramatic
I think so.
moments in history.
It is.
Okay, but now we have atoms,
Yes.
but it's mostly just
It's mainly.
hydrogen and helium.
What about all the other elements?
Yeah,
The stuff that makes up
right.
for everything else.
Yeah, where does that come from?
Like, where do things like carbon,
Right.
oxygen,
Uh-huh.
the stuff we're made of?
Yeah,
Where does all that come from?
that's where stars come in,
Okay. Yeah.
and that's where our atomic journey gets really
I
fascinating.
can't wait.
Yeah,
All right, stars.
yes.
Always love to hear about stars.
Yeah.
So tell me,
Uh-huh.
how do these giant balls of gas
Yeah.
create all these other elements that
Yeah.
we need?
Well, think of stars like massive cosmic furnaces.
Okay.
They're basically factories
All right.
where heavier elements are forged.
So like a cosmic blacksmith or something.
Kinda. Yeah.
But how does it actually happen?
It's all about stellar nucleosynthesis.
Stellar nucleosynthesis.
So stars like our sun
Yeah.
are mainly hydrogen
Right.
deep in their cores.
Okay.
The temperature and pressure are so intense
Yeah.
that hydrogen atoms are forced to fuse together,
Okay.
creating helium.
Right.
And that fusion process releases an enormous amount of energy.
So that's what makes them shine.
That's what makes them shine.
So they're like giant nuclear fusion reactors.
Basically,
And that's powering them
powering them.
and creating new elements.
Creating new elements.
It's incredible.
That's pretty amazing.
But it doesn't just stop at helium.
No, it doesn't.
I mean,
Yeah.
there's going to be more to the story,
As stars age,
right?
their cores get denser and hotter. Yeah.
Some can start fusing helium
Okay.
into even heavier elements.
Found it.
Things like carbon,
Oxygen?
oxygen, nitrogen. Hold on.
Yeah.
So the oxygen I'm breathing right now
Yeah.
was literally cooked up inside a star
It was
billions of years ago.
billions of years ago.
That's amazing.
It's pretty remarkable.
But to get things even heavier,
Yeah.
like gold
Yeah.
or silver,
Uh-huh.
we need something more dramatic.
We need a supernova.
Supernovae.
Shows massive star
I
explosion.
love supernovae.
Yeah.
So tell me more about those.
So supernovae are the spectacular explosive deaths of massive stars.
Okay.
When these stars run out of fuel,
Yeah.
their cores collapse,
Right.
triggering this colossal outward blast of energy.
Wow.
And the temperatures and pressures during a supernova
Yeah.
are far greater than anything found in a regular star's core.
So if a star is like a furnace,
Yeah.
a supernova is like
The ultimate.
the ultimate cosmic pressure cooker. Yeah, exactly.
And that's where we get.
And under these extreme conditions,
Yeah.
heavier elements are forged.
So things like gold, platinum,
uranium,
Okay, yeah.
a cosmic alchemy show,
Yeah.
and then all these newly created elements,
Right.
plus everything else the star has produced,
Yeah.
gets scattered across the universe in the supernova explosion.
It's like a cosmic recycling program.
It is.
So stars create elements. They
Yeah.
explode.
Explode.
They scatter those elements.
Forgot of the elements.
But then what happens?
Well over billions of years,
Yeah.
gravity draws that stardust together,
Okay.
forming these vast clouds of gas and dust
That we call nebulae.
that we call nebulae, exactly.
And so those are basically like nurseries
Yeah.
for new stars and planets.
Yes.
And inside those nebulae,
Yeah,
denser pockets start to collapse under their own gravity.
exactly.
And they spin.
They spin faster and faster,
Yeah.
forming a central protostar.
Surrounded by a swirling disk of gas and dust.
So we've got a protostar
You got a protostar.
and a disk of gas and
A
dust.
disk of gas and dust.
And that's where things get really interesting.
That's where things get really interesting.
Okay, so we've got this swirling disk of stardust
Yeah.
around a newborn star.
Mm-hmm.
What happens next? How do we go from like dust
Right.
to planet?
So it's like
Okay.
a cosmic construction project.
Okay.
Inside that disk,
Mhm.
tiny dust grains are
Yeah.
constantly colliding and sticking together
Okay.
over millions of years.
Yeah.
Those dust grains become pebbles,
Okay.
then boulders,
All right.
then planetesimals.
Planetesimals.
Yeah, small rocky bodies.
So it's like this snowball effect.
It is.
It just keeps getting bigger and bigger
Exactly.
until eventually you have
It's planet.
yeah. So the planetesimals keep colliding and merging,
Okay.
eventually forming protoplanets.
Protoplanet. So like baby planet.
Baby planet.
I like that. Still growing up,
Yeah,
but getting there.
but getting there.
And here's where things get interesting.
Okay, let's hear it.
The location within that disk
Okay.
plays a big role in what kind of planet forms.
Interesting.
So closer to the star, where
Yeah.
it's hotter, you
Right.
get rocky planets like Earth.
Okay, so that makes sense.
Yeah.
The heavy stuff stays close to the sun,
Uh-huh.
forms the rocky planets.
Yeah.
But what about the lighter element?
lightest. Yeah.
The hydrogen and helium?
Right.
I mean, we know they make up gas giants like Jupiter.
Exactly.
So how does that happen?
So further out in the disk,
Okay.
it's colder,
Right.
and those lighter elements are much more abundant.
Okay.
So that's where the gas giants form.
Right.
Their immense gravity pulls in huge amounts of hydrogen and helium,
Okay.
creating those massive atmospheres.
So it's like a cosmic sorting system.
It is like a sorting system.
Heavy element glows in, light elements
Further out.
further out.
Exactly.
That's incredible.
It's pretty amazing.
But okay, so now we've got planets.
Yeah.
We've got rocky planets.
You do.
We've got gas giants.
Yep.
But how do we go from a lifeless planet
Right.
to one teeming with life?
Yeah.
How did those atoms that started in stars?
Yeah, that's the big question.
Yeah.
Become the building blocks of life as we know it.
That is the question, isn't it?
It is.
So what do we know about that?
Well, we don't have all the answers,
Of course not.
but we know that over billions of years,
Yeah.
those atoms combined and recombined in countless ways,
Okay.
forming more and more complex molecules.
So those basic elements like
Yeah.
carbon, hydrogen, oxygen, nitrogen,
Yeah.
forming things like
Yeah.
proteins and carbohydrates,
Yeah.
DNA,
Yeah.
the stuff of life,
The stuff of life.
and all of that happening on early Earth.
So on early Earth,
Yeah.
these complex molecules were concentrated in warm, shallow waters,
Okay.
perhaps near volcanic vents.
Right.
And over unimaginable stretches of time,
Yeah.
these molecules interacted and assembled
Yeah.
into even more intricate structures,
Okay.
eventually leading to the first self-replicating molecules.
Wow. So from stardust to atoms,
It's amazing.
from molecules
Yeah.
to self-replicating molecules.
That's a chain reaction.
It's a chain reaction
across billions of years.
across billions of years,
leading to life.
leading to life, and eventually to us.
And eventually to us.
I am having such a
Yeah.
pale blue dot moment here.
I know.
It's awe-inspiring.
It truly is.
Every atom in our body,
Yeah.
in everything we see,
Everything we see.
was once part of a star,
Yes.
a supernova,
Uh-huh.
a vast cloud of gas and dust.
Exactly.
And when our time is done,
Yeah.
those same atoms
Those same atoms.
will return to the universe.
Yeah.
Maybe become part of new stars,
Yeah.
new planets,
New planets.
perhaps even new life.
Perhaps even new life.
Wow.
It's amazing.
That is a powerful thought.
It is
It really connects us to everything
everything.
in the universe,
Yeah.
past, present, and future.
Exactly.
So after this incredible journey,
Yeah.
what's the biggest takeaway for you?
I think for me, it's the profound sense of interconnectedness.
Yeah.
We are not separate from the cosmos.
Right.
We are part of it.
Mm-hmm.
The atoms in our bodies have been cycling through the universe for billions of years.
Yeah.
We are quite literally
We're stardust.
stardust.
I love that.
It's amazing.
I don't think I'll ever look at the night sky the same way again.
I know, me neither.
Well, thank you so much for taking us on this incredible journey.
Oh, the pleasure was all mine.
It's a story that really reminds us
Yeah,
of the beauty and wonder of the universe
it is.
and our place in it.
And our place in it.
Well, listeners, I think it's safe to say our minds are officially blown.
For sure.
From the Big Bang to the birth of stars,
Yeah.
the formation of planets,
Uh-huh.
and the emergence of life.
What a journey.
What an amazing deep dive.
It was.
I hope you're leaving with a newfound appreciation
Yeah.
for the incredible journey
Yeah.
that those tiny atoms have taken
An amazing.
to become a part of us
Yeah.
and everything around us.
Yeah.
So next time you gaze up at the stars,
Yeah.
remember you're not just looking at them.
Right?
You're connected to them,
Yes.
made of the same stardust.
We are all connected.
Keep exploring,
Keep exploring.
keep questioning,
Keep questioning.
and keep diving deep.
And keep diving deep.